Hi everybody, Mr. Washam here, and here is lesson number 2 over genetics. And so as you can see on the screen here, I've got some of my family that has joined me for this meeting here to talk about genetics. And hopefully you can see from the pictures that the people in my family, we look kind of similar, yet we look a little bit different. So I'm not sure what order they appear on your screen, but you should see a nice big picture of me and my wife and our 2 daughters. And you can see, and you've seen my daughters before, but you can see some of the similarities my daughters have that belong to me, and you can see some of the similarities my daughters have that belong to my wife. And that all has to do with genetics and traits, which is what we're going to talk about today. All right. On another screen, you can see a picture of my family. All right. And so it's got my dad sitting in a chair, and then my mom is standing behind him. And my sister is also standing behind him. You got myself and my brother kneeling down, and there is my wife, Amy. This is back when we were kind of first married. But again, you can see some of the similarities and differences between the 3 siblings there, my brother, my sister, and I, that come from my mom and dad. And then finally, the last picture you see is my grandma and grandpa, which would be this is my dad's parents. But then you can see next to my parents a picture of my dad from when he was in high school, and a picture of me from when I was in grade school. That's a first grade photo of Mr. Washam over there, and a high school photo of his dad. So we're going to quickly run through this presentation on genetics. We'll do a couple examples, and then you guys are going to roll with what are called Punnett Squares. All right, so how did we get here? All right, so early on, there was a guy by the name of Gregor Mendel, and Gregor Mendel, he liked to mess around with pea plants. All right, and so he spent a lot of time taking a look at the pea plants and noticing similarities and differences between them, and that's how kind of genetics got started, and he started working with this. All right, so what Mendel did, this is a long time ago, like 150 years ago, right? We come up with some definitions from his work with pea plants, and what we get is what we call an allele. Now, an allele means that you get 1 from your mom and 1 from your dad, right? So when sex cells, the sperm and the egg, when they meet, when they are passed along from one parent to the other, you're going to get 1 allele from mom, 1 allele from dad. And we refer to that as like a gene or your DNA, right? Okay, now the next thing is what's called a genotype. So a genotype, you're going to see this when we do Punnett Squares. It's a 2-letter combination, right? Now the letters can be anything, any letter of the alphabet, A through Z, right? But you always use a capitalized and a lowercase letter of whatever the letter is you're going to use. So the example here, I've shown you using H's, right? But the easy way to remember genotype, geno starts with G, and so the gene is the genotype. And again, it's just a 2-letter combo that we use to represent that gene. It can be anything. Now, what you actually see is called the phenotype, which starts with P, and P for physical appearance. So whatever you see on somebody, that's called their phenotype. So this could see, oh, I see brown hair. I see green eyes. That's a phenotype. Phenotype is green eyes. We did this tongue roll. You know, can you roll your tongue or not? And maybe if you have freckles or not. Again, these are all examples. There are millions of these, right? Millions of phenotypes out there. So phenotypes are what you can see. Genotypes is the 2-letter combo behind that. Now, what we get is, we talked about this last week with our traits inventory. Some things are what are called dominant, right? A dominant trait always shows up. It always shows. Now, some people can be carrying the recessive trait, but it's hidden by the dominant trait. So the dominant trait always shows, right? Whenever we write dominant traits, we use a capital letter. So again, going back to that H, you write a capital H, capital A, capital J. It doesn't matter. You write a capital letter for whatever you're using to represent that trait. The opposite of dominant is recessive. All right, now some people can carry recessive traits. So I have dark hair. I could carry the trait for blonde hair, which is recessive. My daughter Evelyn has blonde hair, so it's obviously carried. The only way you show a recessive trait is you got to get the recessive trait from mom and the recessive trait from dad. You got to get 2 recessive traits. Right? You got to get 1 from each parent. So if you get both recessive traits, then you show the recessiveness. And this would be things like freckles and blonde hair and blue eyes and a whole lot of other, these are the easy things, right? But a whole lot of other things that aren't as common with the general population, right? The dominant trait is what always shows. The recessive trait, you got to have both of them to get it. So these are things that are not as common, right? And so for recessive traits, we always use the lowercase letter, no matter what. Now, it's got to be the same as the dominant. So if we're using H's, it's just a lowercase h, or a lowercase a, or a lowercase j. It's, whatever the letter is that you're using. All right, so what we get are things called homozygous. Homo means the same. So if you're homozygous, that means you have two of the same letter, right? Either two capitals, so you're homozygous dominant, or two lowercases, which means you're homozygous recessive, which means you have it. All right, you're gonna get that recessive trait. The other one, the one that's probably more common, is what a lot of people have, what's called heterozygous. So hetero means different. So hetero means that you have one dominant and one recessive. So one big H, one little h. So what's going to happen is, because you have the big H, it's going to show it's dominant. However, you carry the small one, the lowercase one, and so you could pass it on. So that's how, like, an offspring may not look just like their parent, because they got the recessive from their parent, even though their parent shows dominant. All right, so that could possibly happen. All right, so we're going to do some practice here, right? So here's some practice with Mendel. All right, so he notices that purple flowers were seen more often than white flowers when he's messing with these pea plants. Purple flowers were seen more often than the white flowers. It's real easy to draw a Punnett square, right? You just draw a square. And then you put like a cross sign in it. Like that. So that is what a Punnett square looks like. And then in your example, you're always given what to write. Now I'm making this one up here, all right? So let's just pretend that he said that purple was dominant and it was seen more often. So we're going to put a big P to represent purple, all right? And let's go ahead and put a lowercase p here. So we're going to say this was the male plant. And the male plant was heterozygous for purple. Hetero because they're different. Big P, little p. Remember, you always have to have a two-letter combo. All right, then over here, this would be the mother plant. And let's just pretend that the mother plant was also heterozygous. Okay, so big P, little p. So there we go. We got the plant. So they both have the probability of showing a little one, right? But we go ahead and work this out. So you always... you write your letters, you take your letters on the top, and you just put one here and one here, one here and one here, and then these go across. You put one here, one there. This one goes across, one here, one here. Now, always write your capital letter first, right? So in this box, we're going to have big P coming down and big P going across. So big P, big P. In this box over here, we're going to have a big P and a little p. Big P coming across, little p coming down. And this box down here, we got a big P and a little p. And then this last box, here's where we actually get a little p and a little p. So you guys can see, oh, there is a possibility that I could have a white plant, right? But all the rest of these, because they have a big, and a big, all because they have that big in there, they're automatically dominant, which means they're going to show purple. Okay? And so there's some explanation on that. So here is an example using bees of what I exactly just did. I used peas. This is using bees, so no difference. You could pretend this one is like brown hair, blonde hair, something like that, but this is how you work out a Punnett square. And we're going to practice this again, and this time we're switching up the letters, again, just to show that you can use different letters. So this we want to cross dominant, which is white, with recessive, which is violet, but you always use the same letter. So again, dominant is big W. Draw my square like that. Okay. And I've got big W, little w. Now again, remember it says because the parents are heterozygous, big W, little w. So then I draw my other parent. Remember, here's one parent, here's the other parent, mom and dad, dad and mom. It doesn't matter, but you go ahead and have both parents. And so I go ahead and fill this in, big, 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 little. When you have letters that kind of look the same, make sure you always write one bigger than the other. So you can always tell big, little again, and then we've got little, little. Now the question on here is, what's the percent the offspring will have violet flowers? So remember, violet is recessive. You got to have both lowercase letters, which is right there to get recessive. I only have one out of 1, 2, 3, 4. So that is 1/4, which is 25% chance that I would have violet flowers. And you can see there on the screen, that's how you fill it in. All right, see if you guys can work this one right here. Pause the video and go ahead and try to work this one. Okay, so here's how your Punnett square should have been set up. It says, in a pea plant, tall pea plants, capital T are dominant, and short P plants are lowercase t, right? So this should have been your setup. Heterozygous, homozygous, recessive for short. And so then I go ahead and work it out. Big T, little and little, big, little, little. That's how I would work it out there. And you can see that I have a 1, 2, or 50% chance of being tall and a 1, 2, or 50% chance of being short in those plants. Last one. Black eyes is dominant over red eyes, so big R is dominant over little r. In rats, make a cross between a homozygous rat with black eyes and a rat with red eyes. And so you can see on the screen it's already been done for you. The question is, what is the possibility of a red eye offspring? So remember, for red eyes, you have to be homozygous recessive or have both lowercase r's. In this case, you see the Punnett square, there's not a chance. They all have a dominant capital R, so there's no chance. There is a 0% chance of having a red-eyed rat from these parents. So again, you can see from the examples of my family here on the screen that traits are passed along from one generation to the next to their offspring, and you have to get one trait from mom, one trait from dad, and that's why sometimes even brothers and sisters look a little bit different. Your children someday may look more like you or more like your spouse, heck, even a little bit more like your grandparents, because those traits, they can skip generations. All right, so we'll be doing some work with this. I hope you guys enjoy Punnett Squares. It is a lot of fun.
Yeah!